Scientists have always been fascinated by the universe's mysteries. However, the more they learn, the more they realize they haven't even begun to scratch the surface. Much of the constraint stems from the capacity of the technology used by astronomers, which has narrowed our knowledge horizon. However, new space equipment has arrived, and the new James Webb Space Telescope promises to reveal even more intriguing aspects of deep space, some of which are frightening. In fact, in this video, we present the weird discovery made by the James Webb Space Telescope at the very edge of the universe. What is at the universe's apex? So how big is the universe really? Want to know more? Don't worry, the Future Space got your back. Humans have always been curious about the world beneath their feet, but as technology has improved, that curiosity has expanded to embrace the cosmos. While ideas for telescopes have been around since the late 16th century, the first working telescopes weren't created until 1608 in the Netherlands. Galileo's use of the telescope to observe the heavens exemplifies the transformative potential of a new lens on the cosmos. Telescopes and the exploration of space are inseparable. The nearest star, Proxima Centauri, is around 4.2 light-years away, and that's because space is so huge. 1 light-year is about 5.88 trillion miles, or 9.6 trillion kilometers. What this indicates is that the distance to Proxima Centauri is 25 trillion miles. Mars, the planet Elon Musk is trying to populate, isn't that far away, but getting there will take many months. Telescopes are used when the distance is great enough. Thanks to the extraordinary power of magnification, we have been able to study these heavenly bodies in more detail than ever before. Many of these telescopes are placed in orbit around a celestial body like the Sun or Earth and use that vantage point to peer out into the cosmos. The Hubble Space Telescope is one such instrument, and it has been sending back breathtaking views of the cosmos for many years. But now we have a better, more powerful eye in space to help us figure out what's happening at the universe's edge. It's the James Webb Space Telescope, and now it's in orbit around the Earth. Even though Galileo probably wouldn't approve of a telescope factory employing people from all over the world and spending millions of dollars on production, proponents insist the investment is worthwhile. The JWST will be the go-to observatory for thousands of astronomers throughout the world during the next decade. From the initial flash of light following the Big Bang, through the creation of solar systems that may support life on planets like Earth, and the evolution of our own solar system, every stage of our universe's history will be scrutinized. Both the cameras and spectrometers used in telescopes have detectors sensitive enough to record extremely weak signals. NIRSPEC is a single device that can observe up to 100 objects concurrently thanks to its micro-shutters, which may be set to different configurations. Webb also has a cryocooler, which is used to bring the mid-infrared detectors of another experiment down to a chilly 7K so that they can function. When we look at the universe as a whole, how do we know what lies beyond it? We can draw from known physical principles and the things we can measure inside our observable universe to make conclusions, such as the fact that the universe is spatially flat on the largest scales and neither positively nor negatively curved to an accuracy of 0.25%. If the rules of physics as we know them are correct, we can set limits on how large the universe can be before it begins to fold in on itself. The most accurate measurements for our extrapolation come from the Sloan Digital Sky Survey and the Planck spacecraft. If the universe does eventually fold in on itself, the visible portion must be at least 250 times larger than the observable zone, as suggested by the two sources. As a result, we can deduce that the unobservable universe has a diameter of at least 23 trillion light-years and a volume of space that is more than 15 million times greater than the volume we can observe, assuming no topological abnormalities. Still, there are good reasons to believe that the unobservable cosmos is far bigger. How far away is the farthest object in the sky that the human eye can detect? For one, there are astronomical objects out there that we just might never get a chance to observe. The present cosmic event horizon is about 16 billion light-years from Earth. This is the farthest away light could ever travel if it started its journey today. This means that the expansion of space-time is greater than the speed of light in the universe beyond 16 billion light-years. The cosmos is expanding faster than light can travel, hence light will never reach us. This also means that no matter what happens today, we will never witness it from outside the cosmic event horizon. However, modern observatories like the James Webb Space Telescope allow us to peer much further. The GN-Z11 galaxy was found to be the farthest away from Earth, at a distance of about 32 billion light-years. Keep in mind that our measurements account for the accelerating distances between objects in the universe. We reach the so-called surface of the final scattering at a distance of around 46 billion light-years from Earth. This is what you will see no matter which way you turn your head. The surface of the last scattering, after recombination and photon decoupling, resembles a homogeneous sphere of fog from which the original photons of cosmic microwave background radiation came. The question, is the universe infinite, arises from the fact that all of our observations have been made with Earth as the center and with time increases with increasing distances. Since Einstein's theory of relativity states that an infinitely flat universe must exist, we can safely deduce that the cosmos has no boundary or limit. The question of whether or not the cosmos has a limited size remains unanswered. How? In other words, while the hot Great Bang may mark the beginning of the observable universe, it does not mark the beginning of space and time. Prior to the Big Bang, the universe underwent a period of cosmic inflation, during which it was filled with energy intrinsic to space itself, expanding at a constant exponential rate and creating new space so rapidly that the smallest physical length would be stretched to the size of the observable universe every 10 raised to the power of -32 seconds. While local inflation has stopped, there are still three major issues that have a bearing on the total volume of our universe. These issues center on the question of whether or not the cosmos can expand forever. They are, first, how huge was the post-inflationary region of the cosmos that created our hot Big Bang? Second, is it true that the universe will continue to expand forever, a phenomenon known as eternal inflation? As for the third, how long did inflation last before it finally petered out, resulting in the hot Big Bang? It is likely that the universe where inflation occurred barely increased to a size larger than what we can observe. Perhaps in a year, evidence for an edge to the universe where inflation occurred will emerge, and we will have to revise our understanding of the universe once more. However, it is also feasible that many other universes exist that are quite similar to our own, with identical physical rules and cosmic structures. Because of this, the tantalizing possibility of complicated life in one of the many worlds out there becomes a reality. There should be an exponentially large number of such bubbles imprisoned within the larger inflating spacetime, and the bubble in which inflation terminated should have a finite size and scale as well. Just where does the universe end and what does it look like? You've definitely heard of flat earthers and been quick to dismiss them. However, if they could generalize their flat surface hypothesis to the entirety of the cosmos, rather than simply the Earth, they might actually be right. For those who are having a hard time picturing a flat universe, take heart. According to Einstein's theory of general relativity, the speed of light is unaffected by gravitational distortions caused by massive objects like stars and black holes. Since the entire observable universe is confined by an event horizon, a boundary over which no light can escape, and is expanding at a rate much faster than the speed of light, this explanation seems to make the most sense. The boundary of the cosmos is defined by something called a particle horizon, which is analogous to the event horizon of a black hole but reversed. However, it's vital to accept that the edge of the cosmos does not exist in the way you might assume it does. How? You may believe that the edge of the universe is a position where you could turn around and see everything, including every galaxy, planet, and star, but this is probably not the best way to think about it, at least in terms of space, which explains that even if you were to reach the edge, there would simply be more universal. That's all for today. We sincerely hope you enjoyed the video. Don't forget to subscribe to our YouTube channel to see more of our incredible videos. You can also watch our other videos that have been specially selected for you. Look forward to seeing you in the next video, and thank you so much for watching.